client. So, as you can see, here are many of options which you can choose from, many options which you can set, and at the end you can also add additional fields down here on this drop box here. I mean, this is very handy for me, for my colleagues at work who understand how to set this up, who understand all of these options, what they mean, how they need to be configured in order to get the VPN client running. On the other hand, we also know that when we set these options, we also need to set firewalls, need to set networking to make it work as it should. But what about everyday users, people who do not understand networks so much, who don't understand what VPN actually is? They know they have to use it for some purposes, but don't know how to configure it in so much details. They just want to download the VPN configuration file, upload it, press connect, and it should connect. I'm not saying that this is wrong or this is bad. This is actually, for me or somebody who understands, very practical. But for normal users at home who are not so proficient in networking, this might be a bit scary. Now, just a story which I have a few months ago. My father, he has some ancient hard disk, external hard disk, on which he has different media, I don't know, some movies and what else he has there. And he calls me and asks me how can he access this device from this hard disk and content on it from other, from tablet, from another PC, from his PC. And once you have it to the router, go on the WebUI of your router. This is a ISP router that we have back in the country. And go there and try to configure it to see what will be offered and how can you access it. And then 10 minutes after, when he tried, he calls me and he says he doesn't understand anything, that what is happening there. I had to go there and make it work, because just for an example, this is the screen that he saw. Now, he is a 65-plus-year-old man. For him, this is a bit confusing. I mean, for most people, it would be a bit confusing. So this is the point that I'm trying to say. The Web UIs, which you see today on the ISPs and the normal routers that you can obtain, are quite complex and can be very, very scary for normal, everyday users. So why Web UI in general? Why would you develop Web UI for your router? Well, first of all, it is a main and starting point of communication with the users. As soon as they get your product, your router, they will, at least they should, connect to it to see how it looks and change all the passwords that they have by default. So it will also simplify setup and customization, because click here, click there, save, it will save very, very quickly. It should save very quickly. And at the end, all of the statistics and data that you have on your router, from traffic to connected devices, etc., they all should be displayed to users so that they can see the health and what is happening on your network. OpenWrt has some existing flavors, as we all know. Lucy, Lucy 2, a bit newer variant, and Gargoyle. Personally, I never used Gargoyle. I mostly used Lucy interface. But when you start working with clients, they don't use these interfaces for their products. They always want to have their own Web UI. Why? Well, Web UI is usually part of the branding, because they usually look in a way that customers want, which will comply with their branding in general, and they want to have it as simple as possible, because they're usually targeting large population of users. So this means that you have to roll out your own Web UI for your customer. Now, what you need to define before you start working on these. First, you need to find what is the project differentiator. What makes this project different? Then, when you have these answers, you start designing and user experience design as well. After that, implementing, which actually has two parts of the implementation, on the backend and on the front end, and they don't go separate, they go along. So when you're developing front end, you need to develop backend functionality as well. And at the end, when you have it all functional, integrating the complete solution into OpenWrt. Now, what is this product differentiator? First, you need to define to who is this router designed for. Are those gamers? Are those everyday people at their homes sitting, maybe opening router once or twice and that's it? Are those some power users in some companies which need to set the networks from time to time and they understand what actually they are doing? So you need to know who your audience is. After that, also, how often this router will be used? Once a year, twice a year, once in 5 years, or every day, every second day. These are all factors which will define your user interface, your user experience, and at the end, the implementation of the complete product. And also, you have to take care if there are some special hardware and software features which you offer. For example, some QoS, which is very powerful, you designed it, and you need to make it to show all the QoS information functionality on WebUI as well. Once you have those, you start working on design. Now, user interface design tells you how the things look, how they will look, how buttons will look, where would be different objects placed on your WebUI. But user experience design is something else. It will actually tell you how your interface will behave. And at this moment, it's important to have an experienced UX team. For example, we back home have a UX team who understand how networks in general and routers work. Because if you don't understand how this actually works in the background, there may be some cases which they will not cover, user will not get certain notifications, and it can be quite problematic later on when the project grows in scope. And then, when we designed, when we have this experience how it should work, we start implementing. First, backend implementation. What is of interest when we say backend implementation in OpenWrt ecosystems? UBus, we all know that UBus is a microbus through which processes can communicate. Then UCI for configuration. UCI configuration files are all located at one place. This even makes it more easier to implement. And at the end, RPCD, remote procedure call daemon, which is used so that the front end invokes calls through the RPC calls to change the router behavior. For example, front end invokes a call to change your LAN IP in configuration file for the network. So this is the basic idea how this can be implemented in OpenWrt ecosystems. Now, when you're dealing with UCI configurations, changing LAN interface, changing some DNS mask options, DHCP options, and other services which have UCI support, it is pretty straightforward. So you just change those options and that's it. Restart the service, it will work. But what if you need some bit more complex behavior that you need to implement? Which comes to mind is, for example, mounting and unmounting USBs. Now for those, you can always write scripts which you can expose to UBus, and then you can invoke those scripts through RPC the same way as you would do UC changes at similar. So this is actually very powerful because it allows you to expand the basic functionality to the functionality which you actually need. And also, besides the scripts, you can write your own binaries which you can expose to UBus and expand the functionality in this way as well. Now, for the front-end part, the trickiest part here is when you start working on the front-end, you develop the front-end on your PC. And then you need to have a mechanism how you would invoke from your PC changes which will affect the router. Because if you will constantly copy-paste files on the router, each time you create some change, it will take a long time for the development. And here, there are two approaches. You can directly tell your front end to send all the calls to your router, or you can use proxy on your PC, which will proxy all the calls that are coming from some machine through the WebUI to router. Now this comes handy, this second approach, when you're developing responsive web design as well. Because today, most customers and general people want to access routers from their mobile phones. I know when I'm home and something is wrong, I just try to connect wirelessly, if I'm reading something from my mobile, wirelessly to my router to see what's going on. So this also approach, this responsive design is very important for your web UI. So how, for example, we mostly use this proxy approach in our company, how it actually looks. Now, this green line from your Wi-Fi device, you invoke a call which will hit the proxy. The proxy will then, through proxy, you will then access web UI, and all the changes that you do from your Wi-Fi device will affect the router. And with the same way back, you will get the response to your Wi-Fi device. So it's very handy when for developing web UIs for tablets, for mobile phones, and even for Wi-Fi, any Wi-Fi device which needs to be supported. What components that you need when developing the web UI, which we, for example, use in the company, are bundler, which will take all the bunch of code that you have, all the 50 files that are there, and bundle them into smaller files, which are then easier to pack into OpenWrt package and later on install. Then you need some JS framework. Of course, you will not use plain JS because frameworks are designed for better code manipulation, higher level of abstractions, and later on better maintenance of your product. And at the end, HTML and CSS, the basic stuff for your design. For example, one of the examples that we used in the company, Webpack as a bundler, plus Vue.js as a JS framework, and HTML with different CSS preprocessors. And this is, once when you have it, how you integrate the solution. The part on your left is the code of your web UI. So as you can see, JS files, CSS, picture files, JSON, you can have everything here. Then this goes through bundler, and only few files are created. One JS, one CSS, one picture file, whatever. And when you have those, you copy those into your OpenWrt package. Now, in this package, you also want to put all of the scripts, all of the binaries that you created for your backend support. And makefile of this package will take care that they are installed on the right places. So, for example, all of the code for web UI will be placed in www folder, and those others will be placed on their locations where they need to be. So this is the complete integration, how at the end it should look like. Of course, as in every development, here are also some potential hiccups which you have to think of when you're developing your web UI. For example, timeouts. So I think, if I recall correctly, RPCD has a 30 seconds timeout. So what does this mean? If you, for example, change LAN IP, in order for it to take effect, you need to restart the network. When you invoke restarting the network, if you have some Wi-Fi drivers, for example, which take a lot of time to restart, then this will take longer than these 30 seconds, and your web UI will never get, it will get timeout response from the backend. Now this is something that we hit sometime when we develop, and you need to take care somehow of this, either patch RPCD or do some other method which will deal with this problem. You can always believe that every restart that you do will go 100% correct, but that's not something for recommend. Also, when dealing with timeouts, for example, this is not a timeout issue, but it's a similar issue. When you change, for example, Wi-Fi SSID, you reset the Wi-Fi, and you are connected on the Wi-Fi to your router. What will happen? You will lose connection. And this is then problematic. What then? UX team, if they are aware of that, they can set some pop-up window saying, please reconnect. And this is why I'm saying that UX team needs to be experienced in this. They need to know that this will happen so that they include this into your design, into your build. These are the cases that will happen a lot. You can also deal with them by automatically reconnecting the background, do some magic there. We managed to do that. We implement these solutions as well, that they automatically connect so that users don't even know that what is happening, that they're reconnected back. So there are some problems which are pretty annoying, and they have to be taken care of as soon as you start developing, because later on implementing that in a bunch of code that you can have can be quite problematic. Then if you're trying to add some additional functionality, such as captive portals, wizards, now those are features that not only that you have to code them for your web UI and implement some backend implementation, you also probably will need to change a bit of code in the existing services, such as HTTPD server or something similar, depending on your approach. So those are not just one-day job. You need to do different aspects of system, change different aspects of system in order for them to implement successfully. Also, security considerations. To use CGI bin or not. If user presses F12 in your browser, they can see UBAS calls, if to mask those or not mask. So those are some considerations which you have to think of when starting working on the project, how to avoid them, how to make your product secure as possible. And at the end, the most annoying third-party software bugs or some unexpected behaviors which are not documented. Those always happen. You always have to deal with those and make them work at the end. I brought some examples of web UIs that we did in the past. Those are just a few of them with different customers of ours. So this is the Sentinel SPS from my presentation this morning. So this is their main dashboard. As you can see, it's quite, the colors are complementary. You can see everything clearly. The design is minimalistic, but yet it provides you enough information to see what's going on your device. This is the simplified version of this dashboard. So you have this circle in the middle on which you can click on sides and get the information of connected devices if the security is running and similar. This is another project that we did for the remote management of ours called Miyagi. This is the login screen, and this is an example of file. Then this is the project that we worked on, Portal. This is a device which concentrates over powerful Wi-Fi which they have, and as you can see here, the main target was to create as minimal as possible design so that users don't get lost, and simple colors. Everything is, when you look at it, everything is clear what you need to do and how to make changes for this web UI. This is another example of the same for VPN client, PPTP connection here. This is actually a work in progress screenshot here that I have for this VPN. We also tend to implement the different language supports in our projects. As you can see here, you can choose the language which you want for your web UI. At the end, it is a bit blurry, but you can see it. This is the latest project that we did and are working on. This is a gaming router. As you can see here, for example, for gamers, speed test, which gives you the ping information, upload, download, which is important when you are a gamer, what's your ping. As you can see, complete design is based around those important features for the average gamer today. And just a few of those, screenshots more. So here you can see device prioritization. They allow to prioritize devices which will have better connections, which will have bit not so good connections, so to say, and you can, in this drag and drop, move your devices to prioritize them or not to prioritize them. And also the killer feature they have is shown up there, and here's the screenshot of all of the connected devices at this moment, if they are prioritized or not. And that's it. Thank you for your time.
Thank you, Davor. And tells me the coffee break is running 2 minutes late, so you can just slowly stretch and get out of your chair and wander over and chat with people on your way over to the coffee machine. But we're going to get back here. Actually, if you can come back just a little bit early, we actually squeezed in one more lightning talk. Instead of one lightning talk, we have two, or maybe, or do we still have enough time? Okay, come back at, yeah, at 4:45. So you actually have a good long chance to break and chat.